Today I will explain Newton's law of gravitation. Suppose we have two bodies. Mass of this body is m1, mass of this body is m2. As per Newton's law of gravitation, if there are two bodies, then both of them will have force of attraction. This body will have force in this direction, this body will have force in this direction. And then force F1 and F2, suppose this is F1, this is F2, then F1 and F2 will be equal and will be equal to M1 M2 by R square into G, where G is universal constant and remains same anywhere in the universe, and R is the distance between these two bodies. Here it is assumed that body mass is concentrated here and this body mass is concentrated here, then distance between these 2 points is R, and both mass may be equal or different, but force will be equal. Now force is also equal to mass into acceleration. Suppose this is acceleration a1. So this F1 is equal to m1 a1 also and this also. If we make this and this equal, then m1 will get cancelled out. Only m2 will remain here. So a1 will be equal to G into m2 by r square, G m2 by r square. Similarly here, force F2 will be equal to mass m2 into acceleration a2. When this and this are equal, then m2 will cancel out and we get a2 is equal to G m1 by r square. So here there are two things, one is force, one is acceleration. Here also two things, force F2, acceleration a2. In both the cases, force will be equal. Whatever mass m1 and m2 are there, and this force will be proportional to their masses and inversely proportional to distance. Now force are equal, but acceleration a1 and a2 are not. This is a1, this depends upon the value of m2. This means acceleration of this is depending on mass m2. Similarly, acceleration a2 is depending upon mass m1. This mass m1 decides acceleration of this body. Similarly, this mass decided acceleration of this body. So if m1 is more, then acceleration of this body will be more, a2 will be more. Here I have shown two bodies again. They have force of attraction which is equal. But I have shown these two bodies looks like in horizontal position. Suppose instead of horizontal they are like this. Still same force will come. This force will be equal to this force. Suppose they are like this, still force will be there. But now this force will be in this direction, this force will be in this direction. Force will be always towards other mass. Suppose it is like this, then also force will be there. These two masses can be anywhere, here, 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 maybe like this. Force will be there and it will remain same. Here there were two masses, here I have three. So all three will attract to each other. Between this and this, force will be like this. And these two force will be equal and will depend upon this mass and this mass. Similarly, between these two, force will come, a force of attraction will be there towards each other. and this force will depend upon mass of this and mass of this M2. Similarly, between these two, force of attraction will be there and will be function of M2 and M3. These two are equal. These two are equal. These two are equal. But this and this is not equal. Because this force depends upon M1 and M2. This force depends upon M1 and M3. So this force will be different than this force and will be different than this force. Now here, suppose in between these two, I keep another mass. Then what will happen? Earlier there was mass M1 and M2, M1 and M2. This force will continue. It will not be affected by this mass. In addition to earlier force, there will be two other forces. One between this mass and this mass, M1 and M3, and the third one between this M3 and M2. So one force M1 and M2, another one between M1 and M3, third one between M3 and M2. This will not affect earlier force. Now here I have shown one very big mass and one small mass. This very big mass may be Earth also. So this mass and this big mass will have force of attraction. So both will have force which will be equal. Both will have acceleration also. But acceleration of each item depends upon mass of other. Because this mass is more, so acceleration of this M2 will be more. So this will start moving this side fast because this mass is more. Similarly, suppose this and this acceleration will be very less or zero because this mass is very less compared to this. Now suppose this item is here. Then again it will start moving up towards center because of acceleration. But both will have force like this. And those force will be equal. I have not shown those force. I have shown only acceleration here. Now suppose this is here. Then again it will move towards center because of force of attraction. Because this mass is much more than this. Similarly, because this mass is more, the acceleration of this is more, so this will move. Similarly, suppose this mass is here, so again it will move towards center. So this mass can be anywhere, it will start moving towards center of the earth because of force of attraction, because of gravitational force. Now here again I have shown two masses M1 and M2. They will have force of attraction towards each other. Now suppose this big body is consists of three parts. This part and this part. Then what will happen? This particle, this mass will have three forces. One for this, one for this, one for this. Like this. This one and this one will have force of attraction. This is center mass of this. This is mass center of this. This C3 is the mass center of this piece. So this one and this one will have force of attraction. This one and this one again will have force of attraction. This one and this one again will have force of attraction. But these three forces together will be equal to this force. The summation of these three will not be different than this. This will be same because total item is same. Now here this mass is having three forces. Suppose I move this mass from this point to inside, say like this. So this mass and this mass will have force of attraction. Here I have not shown, there will be force. Similarly, this mass and this will have force of attraction. This is the center of this, mass center of this. Similarly, mass center of this portion is this. So there will be force of attraction between this M2 and this. Here again force will be there, I have not shown. Now here, this particle or this mass will have three forces, one this side, one this side, one this side. Earlier, it was having like this. This force will, total of these forces will be more than this total of these forces because all towards same direction. But here this and this will get cancelled. So when you will add all these three, this force will be much less than this. So when you move somebody inside the earth, force of attraction or gravitational force comes down. It will reduce. Today we will close here itself.